Today, we want to look a little bit more add a little bit more detail about the linear equations we were dealing with yesterday and the relationship between the point slope equation of a line and the standard-ish equation of a line, because we're going to want to see what the numbers tell us in the point slope equation of a plane. I guess it would be the point slope and slope equation of a plane and the standard equation of a plane. What we discovered is that the standard equation of a line has a coefficient of the rise for the x, so ax. That's not how I wanted to phrase it. I don't know if this is a more coffee problem or a less coffee problem, but I know what solution I'm going to apply. In the standard equation of a line, the coefficient of x and the coefficient of y have the minus rise and the run. Let's translate this into vectors. So here is a vector. Here we have a vector with the rise and the run. It's a 2/3 slope. So I did 2 and then 3 for those of you who have graph paper and are trying to make it match. So the vector that describes this direction the horizontal component is the run and the vertical component is the rise. Because of what we want the slope to represent. We want the slope to represent how much y increases or decreases when x increases by 1. That's what we want the slope to represent. We want it to be a rate of change. How is y changing with respect to x? But when we translate that into vectors, the run is the horizontal component and the rise is the vertical component. So let's take a look over here at our standard equation and think about a vector perpendicular to this vector that's describing the line. The line. And in typical fashion, I put all this stuff here right in the way of where I wanted to draw the line. So we're just going to have to imagine that the line is there. The perpendicular slope will be the opposite and the reciprocal. So instead of 2/3, it'll be a 3 over -2. And so the components of that perpendicular vector, that vector that is normal to the line, we have a -1 times the run, or sorry, a -1 times our original rise, minus rise. And our run is vertical. And so notice that that vector that's perpendicular is related to our original vector. the x coordinate or the horizontal component is the minus times the minus the rise and the run. And notice that the coordinates or the components of that perpendicular vector are the coefficients that we see in the standard form of the line. Coefficients in standard form are the components of the perpendicular vector. The coefficients of the standard form are the components of the orthogonal line. Orthogonal being perpendicular. Because Calc 3 is the easiest of the calculuses, it's all one calculus. The easiest part of calculus, let's phrase it that way. We should expect a similar thing to happen when we upgrade our equation of a plane from its point, slope, and slope form to its standard form. So if we have the point, slope form of a plane, z equals z naught plus dz dx times x minus x naught plus dz dy y minus y naught. We can do the same and write a standard equation for this plane. Or we could have the coefficient with x minus x naught, y minus y naught, z minus z naught. Or we could multiply that out the same way we did with the standard form of a line. And just gather up all those constants as one constant. The same way we did ax plus by equals c. And the same thing should happen. The coefficients of the standard form should give us a vector perpendicular to the plane. And that's what happens. The coefficients of the standard form are the components of the vector perpendicular or orthogonal to the plane. To make things match better, are the components of the vector orthogonal to the line. Coefficients in standard form are the components of the normal vector. Normal to our original line, normal to our plane. How's everybody okay? Remember, we had multiple ways of describing a plane. I could say the plane is the span of these two vectors, every linear combination of two non-collinear vectors, or I could say everything perpendicular to this normal vector. The span of these two vectors, or everything perpendicular to the normal vector. Yes. Yeah, we're not worried about the location, right? This question is concerning the A, the B, and the C. That's going to determine the how the plane is oriented. D will just move the plane up and down. So changing the value of D will move the plane up and down. And in the same way it worked with lines. Like if I look at the standard form, AX plus BY equals C. If I change the value of C, that's just going to move my my line up. Oh, it's a line. My line up and down. So we're not worried about where it is. We're just worried about what direction things are pointing. That's the most important part. Any questions? Yeah. Well, I kind of I absorb any kind of sign changes because I just called them A, B, and C, where I was really up here trying to highlight the fact that we have minus the rise. So I could put a minus rise over here and then a run. So there will be sign changes depending on what we write up here. If this is a 5, notice that there's also a couple of denominators that we're clearing out, the delta X and the delta Y. So we're kind of like multiplying through, changing the coefficient of Z. So there are some other changes going on when we start manipulating things with actual numbers. But whatever the coefficients are down here, once all that stuff is sorted out, that will be the coefficients. That will be the components of the normal vector. That's what we want to recognize. How's everybody okay? I told you, Calc 3 is the easiest part of calculus. All the calculus stuff is already back in your subconscious. Right now, we're just increasing the number of inputs for our functions. So here's what we want to notice. We want to notice that we have a few ways of constructing a plane depending on what information that we have, the information that we have. If we can see how Z is changing with respect to X and how Z is changing with respect to Y, then we just find a point and then use the point slope version of a plane. In the same way as if I give you a point and a slope, if I give you dy dx or delta y delta x over delta x and a point, that's the equation of the line you would write. If I give you information about a point and the normal vector, you would just take the normal vector, drop in the coefficients, and drop in the point, and then you could sort out what your equation is. So we got a few ways of finding the equation of a plane depending on the information that we're given. Any questions? Comments? That's going to be our next quiz. I wanted quiz 2 to be about linear functions. It's all going to be planes. It's going to be find the equation of the plane. And I'm just going to give you various pieces of information and ask you to find the equation of the plane. I might say it goes through this point, x naught, y naught, z naught, and here's a vector normal to the plane, which would be the easiest version because you could just like drop it into your standard form. But then I'll be like, I'll write it in standard form. So you have to do some algebra and work out what this constant is at the end. Then you're going to have to figure out how you're going to type that into Canvas. Like, oh, did I put spaces in between the pluses and spaces? That is it like AX space plus space BY space plus space CZ space equals space D, or did I just cram it all together? I guess we'll just have to wonder. If I give you a table of values and say, here's some values from the plane, then it's going to be easy to see how z is changing with respect to x and how y is changing, z is changing with respect to y. In that case, you just grab one of the points and drop it into your point slope form. Or just like with equations of lines, I can give you, I can ask you to find the equation of a line by giving you 2 points, where you find the direction between the 2 points, the slope, and then you put that together into a point slope equation. I would have to define a plane that will require 3 points. But with 3 points, you can make 2 vectors. With 2 vectors, you can find a normal vector. Same stuff, just with more dimensions. It's the same issue you get to when you first start physics. Let's do this in a vacuum and let's ignore friction because that just complicates things. Then later on, once you get the basics down and you can work in a frictionless vacuum, then we can start throwing in friction. Then we can start speeding things up to a certain point. Because at a certain point, if we start getting to a significant fraction of the speed of light, all of a sudden stuff changes again. Thanks, Einstein. He's not the one that caused relativity. Reality caused that. He's the one who's like, hey, this is going to get more complicated. Like, oh, jeez. You know what I mean? Any questions? Comment? Slide along. I have a theory about Einstein. So everybody knows who Einstein is, right? Albert Einstein. Relativity, right? Very important idea. Name another physicist since Albert Einstein and their idea. Have we got one? What's that? Me? Oh, Elon Musk? No, Elon Musk is a moron. Every time he tweets, he reveals just how dumb he is. If Elon Musk never installed Twitter, we would still walk around thinking he's a genius. But he decides he wants to tweet stuff demonstrating just how dumb he is. This is why I don't have a Twitter account, because I don't want to reveal to the world past my classroom how dumb I am. That's what would happen. I don't know. Maybe it would. But here's the thing. This is my theory about Einstein. Einstein is famous less about it for his awesome idea, which is unquestionably an awesome idea. But I think it's because Albert Einstein is not an intelligence-based character. It's because he's a charisma-based character. Albert Einstein is a rock star, not because he plays rock music and that's what made him famous, because he has rock star inside. It just expressed itself with physics. We talk about cloning Albert Einstein. I think if you clone Albert Einstein, like in 2022, I don't know that you get another physicist. I think it would depend on his musical ability. I think it's like, oh no, I want to be a rock star. I think that's why he was famous, not because of the idea. This room, it's a little bit easier question to ask for someone to explain relativity. But the general population is well aware of who Albert Einstein is. He is a smart guy. And yet I'm like, oh, yeah, Albert Einstein, smart guy. Let's talk about relativity. He's like, oh, no. I just know Albert Einstein. I know relativity, E equals mc squared. That's the end of it. You know what I mean? That's my theory anyway. Albert Einstein is a charisma-based character that happens to have very high intelligence. I don't know how I would prove this theory. I don't know even if I care to prove this theory. It's just an idea that I want to put out there into the world. Anyway, any questions on this equation of the plane business? You might notice that I described the three ways I'm going to ask you to find the equation of a plane. I haven't done any examples. That's your job. You find the equation of a plane. How's everybody? Okay. There's like this quote that Albert Einstein said, and it's often used as kind of an inspiring thing. Do not worry about your difficulties. It goes along the lines of, don't worry about your difficulties in math. I assure you mine are greater still. And it's created this myth that Einstein was not very good at math. This is 100% false. Einstein was one of the great mathematicians of the 20th century. No question, hands down, easily crushed everybody. He is one of the great mathematicians. He taught himself calculus because the school wouldn't keep up with it. Now, he might have done poorly in school because the school couldn't keep up with him, but he did not struggle with math. When he says, I have difficulties in math, it's because the physics he was doing, we had to invent, like I was there, new math had to be invented to deal with this physics. That's difficulty in mathematics. So it's kind of a jerk quote. It's like, oh, you think you got problems? You should see what I have to deal with. Kind of changes the tone of the whole thing, doesn't it? But do not go around believing that Einstein was bad at math. I want people to be inspired. I want people to look at their struggles and say, I can deal with this and move forward. I don't want that to be based on a lie. And my belief is that math is open to everybody. That's just true. All it wants from you is time. All that math wants from you is time. For some of you, it's going to be less time than others. That's all. It's the same with anything else. Any questions? What I'm saying is that there's nothing physically stopping you from learning math to any degree that you want. There's nothing that's going to be physically stopping you from doing it. I think too many people have decided that they are being physically stopped by their own brain from learning math, when in reality, they don't just want to admit that they don't want to do it. Just be like, oh, I don't really want to. Here's a fact. I'm a terrible basketball player. Makes sense. I have spent 0 time trying to become a good basketball player. I don't think at this point in my life, I will become a good basketball player ever. I think that thing where he said, oh, you can be whatever you want. It's never too late. It's too late for me to become a pro basketball player. If I started training to the degree that I would become a pro basketball player, I would just fall apart. My joints would be like, oh, no, you are not doing this. How about tennis? Like, oh, no, that's even worse. How about video tennis? All right, video games are okay. But then my eye-hand coordination is going to be like, oh, hey, you know how your eyes are supposed to focus on the same thing? And I'm like, oh, yeah. And it's like, oh, not anymore. Oh, man. So, you know what I mean? I want people to be inspired, but I don't want to be based on a lie. Einstein was an excellent mathematician. He may have struggled in school, not because math. He may have fallen behind in the studies from his class that his teacher wanted him to do because he was reading calculus books and said, well, I have to learn this so I can explore my ideas. You know what I mean? Anyway. How's everybody okay? All right, so I've got to write quiz 2, and it will be find the equation of the plane 3 times. And then your big challenge is not only going to be finding the equation of the plane, but learning how to communicate that through Canvas. That's going to do it for today. I will see you all on tomorrow, and we're going to find out tomorrow just how much math you still already know. I'm going to be like all derivatives. You're going to be all, whoa. I'm like, oh, you already know derivatives. It's no problem. That's it for today. I'll see you all on tomorrow. Have a good day, and thanks for playing.